Today I will continue with DNE 992. Okay, the third lecture, I believe. Okay. So today's session is about a bivariate analysis. I'll be giving you a little bit of introduction on bivariate analysis, a continuity from our previous lecture on univariate analysis. Okay. So in bivariate analysis, we are dealing with two variables compared to one variable in univariate analysis. So when we have two variables, what we are looking for is not just describing those two variables independently, but also to identify the relationship, if any, okay, the relationship between those two variables. Okay, so this is what is unique about bivariate analysis in comparison to univariate analysis. Okay, so first of all, we have to entertain the idea of a variable. Okay, so the variable is an object, event, idea, feeling, time period, or any other type of category which you are trying to measure. Okay, so there are two types of variables, namely the independent and dependent variables. Okay, so the independent variable, or the IV, it stands alone. Okay, so it is not changed by other variables that you are trying to measure. Okay, so it is the variable that is changed or controlled to test the effects on the dependent variables. So the IV is basically, we manipulate the IV to recognize the changes that happens to the dependent variables, or the DV. Okay, so this is something that you need to uh, properly cement in your head, okay, between the IV and the DV. Okay, you can't get this wrong. Okay, so you can't afford that. So the dependent variables, okay, is something that depends on other factors. So it is the variable being tested or being measured. Okay, so it changed because something that we did to the independent variable. So the independent variable are the variables that we manipulate, and the dependent variables are the dependent that we measure. Okay, so usually you are looking for a relationship between two things, okay, which is known as a causality. Okay, so you are trying to find what makes the dependent variable changes the way it does. Okay, so many people have trouble remembering which is the independent and which is the dependent variable. So they got these two, the wrong way. All right. So just remember that the independent, because it is independent, okay, it causes a change to the dependent variable. So it is impossible. It isn't possible that dependent variable could cause a change in independent variable, because dependent variable depends on the independent variable. So you can remember it in that way. Okay. So for example, time spent studying. Okay, that is a variable, a factor. Okay, causes a change in test score. So the test score is another variable. So the independent variable here is the time spent studying, and the dependent variable is test score. So when we want to study this, okay, we are manipulating time spent studying and how it affects the test score. So independent affects the dependent. So it's not the other way around. Okay, it isn't possible that test score would cause a change in time spent studying. So that is very weird. Okay, how can a test score would affect the time spent in studying? So it's supposed to be time spent studying causes a change in the test score. Okay, or independent affects the dependent. Okay, so there is a clip from one of a very famous movie. So in that clip, the Merovingian is trying to explain about causality. Okay, so in causality, there is action, reaction, cause, and the effect. IV and the TV, they manipulated and the measured. So that's what I've come in the diagram here. Is causality. We have cause, we have effect. So in any applied research today, that's what we're trying to find. Yeah, what is the cause and how does it affect? So you would have the independent variable as the cause, as the variable that is being manipulated to find how it affects the dependent variable, where the degree of the effect is being measured. Okay, so we want to see how we manipulate the IV, and then we want to try to measure the effect on the DV. Okay. So when conducting research, analysts attempt to measure the cause and effect to draw conclusion among the variables. Okay, so they would have a set of variables. Okay, from their research questions or from their hypothesis, and they want to draw conclusions of the relationship between those variables. So bivariate analysis is simultaneous analysis of two variables. Okay, so it explores the concept of relationship. Okay, the causality. Okay, between those two variables. One, whether there exists an association, whether there exists a relationship between those two group of variables. Okay, and then if there is an association among those two groups of variables or those two variables, we want to measure the strength of this association of the relationship. So how strong is that connection? And number three, whether there are differences between those two variables. Okay, so we want to also try to identify that and the significance of these differences. So if there are any differences, okay, you might find one, but is it significant? Okay. So the bivariate studies are different from univariate studies because it allows for the researcher to analyze the relationship between those two variables. If we can still recall, the objective of univariate analysis is just barely to describe that one variable. So it's just describing the variable, but Over here, since we already have two variables, so we can also try to identify the relationship between those two variables. Okay, so often denoted as x and y. In order to test simple hypotheses of association and causality. Okay. So there are essentially four steps in conducting bivariate analysis. So as follows. Step one, define the nature of relationship. This is where we want to try to find whether there are any relationship. Step two, if there are, identify if there is a relationship, or normally just one relationship, but there might be more. Step two, identify the type and direction of the relationship. Okay. Step three, determine if the relationship is statistically significant. And step four, identify the strength of the relationship. So one, identify the nature. Two, identify the type. Three, determine the significance. Four, identify the strength. Okay, so in step one, if you're testing the relationship of a class size and grade, you want to report the following. The data show a relationship between class size and grades. So here we have two variables. One is the class size, okay, and number two is the grades of the students in those classes. Okay, so out of the survey, the researcher found out that smaller class sizes. Okay, so the word or the term small is defined as 20 students or less. Okay, have a grade point or average of 4.4. Okay, so this must be a 5 scale GPA. Okay, so they have a 4.4 GPA. Where the larger class sizes, okay, 21 students up to 100 students, have a grade point average of 3.1. So this demonstrates that students in smaller classes earn grades that are 30% higher than those in large classes. Okay, so here I have identified the nature of the relationship. Next, we want to determine the type and direction. So we need to determine which of the four levels of measurement you will use for your data. If you remember our previous lecture on level of measurement, okay, whether you will use nominal, ordinal, scale, or ratio type of data. So correlation describes the relationship or degree of association that exists between the variables. So we want to identify the correlation. So we can conclude that a decrease in the number of students have a positive effect on grades. So in this observation, okay, in this survey, we identified that a decrease in the number of students in a class would eventually boost up the students' grades. Okay, so this is known as the negative correlation, where we decrease one variable, the other variable will continue to rise. So one variable goes down, another variable goes up. So this is a negative correlation. If it's a positive, one variable goes up, the other also will go up. If it goes down, the other will go down. So this is a positive. But in this observation, it is a negative correlation. An increase in number of students led to an increase in grades. So that is a positive correlation if that researcher has okay. So if that researcher has identified it as identified as like that lah, but in this example, it is a negative correlation. Next is step 3, determine the relationship is statistically significant. So we already know there is a relationship between those two variables, and it is a negative correlation. But we want to know, is it significant? Okay, so statistical significance is used to determine whether the results are significant enough to truly make a connection. So in other words, do we think the result occurred by chance, or do we truly accept to see the same results with another similar study population? So just because we have found this negative correlation in this particular survey, does it mean that we are going to find this a similar relationship in other surveys? Okay, that uses the same procedures. Okay, so or does it just by chance? Okay, so a relationship is considered significant. Okay, the association seen in the sample where it does not occur randomly or by chance, if it has a significance level of 0.5. Oh, sorry, 0.05. Okay, so 0.05 means that only 5 of 100 times, okay, that the pattern of observation of those two variables that we have measured occurred by chance. Okay, so there's only like 5% chance that the thing that we have observed happens by coincidence. That is what it's trying to say by 0.05. Okay, so which means that 95%. So if we repeat this survey in other population, there is a 95% chance that we would find the similar results. Okay, and this happens because of the research itself. It does not happen because of chance. Okay. So step number 4, identify the strength of the relationship. Okay, to determine whether a bivariate correlation is significant, researchers should researchers choose a standard formula depending on the type of data used. Okay, so here they would use a Pearson's correlation coefficient that measures the strength of linear relationship between x and y. So because we only have like two variables here, okay, and so we want to observe the linear relationship. So we use the Pearson's correlation coefficient. So the relationship between the two ordinal variables can be measured by using a formula entitled Spearman's rule. So Spearman's rule calculates the correlation coefficient on rankings rather than the actual data. Okay. So these types of analysis is actually beyond the scope of these introductory videos, but I would suggest you to find good training videos that are available on the internet. Okay. So a brief example here, there is okay, graph at the top right hand corner there. You can see correlation, coefficient, variation. Okay, so that Spearman's rule that we're talking about, okay, will vary between -1 and +1. So if it's a negative one, being a perfect negative correlation. So the middle one here, so that is a perfect negative, meaning that it means that if variable y decrease 1 unit, variable x will increase 1 unit. Okay, so y decrease 1, x increase 1. So that is a perfect negative correlation. Okay, so positive 1 being a perfect positive correlation. So if y increase 1 unit, x will increase 1 unit. If y decreases 1 unit, x will decrease 1 unit. That is a perfect positive correlation. Okay, 0 meaning there's no relationship between the two. So if we plot in the graph our observation and the plot is just scattered all over the place, we are unable to write a line through those plots. Means that there is no observable correlation. Okay, so other formulas that can be used to measure the significance based on the type of data used, okay, level of measurement, okay, including Kendall tau B, tau C, Goodman, Kruskal gamma, chi-square, Lambda A, Whitney U test, and Wilcoxon sign rank test. So these are other tests that you can use, which is obviously beyond the scope of this lecture. Okay. You can obviously find some very good videos online on this. Okay. All right. So next we have a look at this video. Okay. So that is a bit of introduction on Bivariate analysis on to decide which type of measures that you are going to use, which type of approach or formulas that you're going to use. Okay, so it's been mentioned there about null hypothesis and whatnot. Okay, so it's only obvious that we move on to hypothesis testing. Okay, so bivariate analysis allows us to test hypotheses about a relationship between two nominal or ordinal level variables. Okay, the first two levels, nominal or ordinal. Okay, so steps in testing a hypothesis. Okay, state the research of hypothesis. Okay, so state the research hypothesis. You have to come up with a research hypothesis and then state the null hypothesis. So an easy way to think about this is the research hypothesis is all about yes, yes, yes. Okay, agreed, agreed. Where the null hypothesis is about no, no, no. It's the opposite of the research hypothesis. And then choose a level of statistical significance or the alpha level that you're going to use. Is it 98 or 95%? And then select and compute the test statistic and then make a decision regarding whether to accept or reject the null hypothesis. So there is a tradition in research that it's easier to prove the null hypothesis is true rather than trying to prove that the research hypothesis is true. Okay, so it's always about to accept or to reject the null hypothesis. If they accept the null hypothesis, and then they will reject the research hypothesis. If they reject, in the other hand, if they reject the null hypothesis, then the researcher would have to accept the research hypothesis. Okay, so an example here, alt hypothesis or the research hypothesis, okay, known also as the alternative hypothesis. there is a relationship. You see, there is a relationship. It's always yes, yes, yes. Okay, so there is a relationship between income level and education for respondents in a survey of BA students. So there is, yes, there is a relationship between income level and education. Okay, the null hypothesis is there is no relationship. Okay, it's all about no, 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 no. Okay, so there is no relationship between income level and the education for respondents in a survey of BA students. So this study has set the confidence level at 0.05. Okay, so if we that's not like the one that we have covered previously. Okay, the significance level. Okay, 0.05, meaning that only 5 out of 100 times the pattern observation will happen because of chance. Okay. Okay, so so this is a video on hypothesis testing. Okay, so that is the process of accepting or rejecting the null hypothesis. Okay, so next we move on about this is about the differences between univariate and bivariate data. So univariate data, we only it involves a single variable, where bivariate involves two. Univariate does not deal with causes or relationship, where the bivariate data does. Univariate data, the major purpose of univariate analysis is to describe, where the main purpose of bivariate analysis is to explain. So in bivariate data, you have a lot more things to play with compared to univariate data. Okay, so this is shown when in univariate data we have central tendency, dispersion, frequency distribution, and to show it all we can use bar graph, histogram, pie chart, and etc. Where in bivariate data, we it's an analysis of two variables simultaneously. We have correlation, comparison, relationship, causes, explanation. Okay, so tables where one variable is contingent on the values of other variables. Okay, we can use that. And we have independent and dependent variables. So a sample question in univariate data, how many of the students in the freshman class are female? So you just want to know the numbers. But in a bivariate data, the question is a lot more complex. Okay, is there a relationship between the number of females in computer programming and their scores in mathematics? Okay, so we have two variables. Number of females, okay, in computer programming, and their scores, okay, in mathematics. Okay, so those are type of question that we want to ask in bivariate data. Okay, so we are done with bivariate analysis. Now we move on to multivariate analysis. So multivariate studies are similar to bivariate studies, but multivariate studies have more than one dependent variable. So we still have independent and dependent, but the dependent is more than one. So multivariate data analysis refers to any statistical technique used to analyze data that arises from more than one variable. So normally this essentially models reality where each situation, product, or decision involves more than a single variable. So in the real world, it's not as easy as how one variable affects the other. Is sometimes one or more variable affects one or more other variables. Okay. For example, if an advertiser wanted to examine the effectiveness of three different banner ads on a popular website, the advertiser could measure the ads click rate for both men and women. So the researchers could then use the multivariate statistical analysis to examine the relationship between all of the variables. So normally, this multivariate analysis technique represent a variety of mathematical models, okay, used to measure and quantify outcomes taken into account in important factors that can influence this relationship. So usually we come up with model because we are trying to identify relationship of many independent and dependent variables, okay. So there are several multivariate and statistical techniques that one can use to examine the relationship among variables. The most popular is multiple regression analysis, which helps one understand how the typical value of the dependent variable changes when any one of the independent variable is varied or being manipulated while the other independent variable are held fixed. So other techniques include factor analysis, path analysis, multiple analysis of variant or MANOVA. So obviously those technique is beyond the scope of this video. Okay, so if you want to use other multiple variable analysis, you can use like models, like the one I use, SAM, structure equation modeling, or PLS, or a combination of both. Okay, you would have a lot more degree of freedom to identify the relationship between these variables. Okay. Okay, so with that, we have ended the presentation. Thank you for tuning in. If you would like to know more about those statistical analysis, I would suggest either you find more information initially, try to find more information about it online. There's a lot of website training videos and literatures that would cover those topics. Or you can go to specialized training courses that would train you on how to use this type of analysis correctly. But what's important is that you must know exactly which type of analysis that you would require for your research. Okay. So with that, I end this session. Thank you very much for tuning in. Okay, see you again next week. Assalamualaikum warahmatullahi wabarakatuh.